Hello everybody, and welcome back to another Big Ideas lesson. We're continuing with Unit 7 on 7.7. And the thing about 7.7 is this section is incredibly short. You may remember all the way back in 7.3, where we learned a couple of neat tricks. I'm sorry, it was 7.3. Where we learned a couple of tricks when it came to solving problems like this. When it came to, for instance, problems of the form a plus b and a minus b. I called this section sort of the life hack section, and I mentioned that there was only one pattern that we would really be using. Although they're all useful, this one is unsolvable any other way, basically. The difference of two squares pattern is what we're talking about today. And when you see a problem that looks like it's a difference of two squares, this is probably going to be the only way we're going to be learning how to solve them. These other two methods, the perfect square trinomial patterns, are neat if you know them, but not necessarily critical or crucial. The difference of two squares pattern works like this. You may remember all the way back in 7.3, if you had two terms, two binomials, and they had the same first term and the same last term, let's say 4, where one was being added and one was being subtracted, we learned that you didn't really need to FOIL it. You would just say the answer is the square of the first term, so x squared, and the last term squared with a minus sign in between. This is the reverse of that trick. This trick, the difference of two squares pattern, tells us that if you see two perfect squares with a subtraction sign in between, you don't need to solve the problem. You can just write out your answer. The pattern works like this. Let's say we have x squared minus 9, just like the example over here. We know that x squared is a perfect square. What's x squared made out of? Well, x squared is just x times x. And what's 9 made out of? Well, 9 is just 3 times 3. So, do we have two squares? Check. We have two squares. The subtraction sign in between is crucial. It must be a subtraction sign. That's where the difference part comes from. So we have a difference in the middle of two squares. So we are allowed to use the pattern. And the pattern says we take the square root of the first term and the square root of the second term, and those are the two terms in both our binomials. So the square root of x squared, we mentioned already, it's x, because x times x is x squared. So the square root of x squared is just x. The square root of 9 is 3, because 3 times 3 is 9. All we do now is we make it so that one of them has a plus sign and one of them has a minus sign, and we're done. That's the difference of two squares pattern. So let's take a look at the next page. Let's take a look at page 227, where there are a bunch of examples like this. I want us to try out problem number 2, and then I want us to take a look together at problem number 6. Problem number 2 is t squared minus 81. So first thing we need to check is there a difference? Yes, there's a subtraction sign, so we know that it's a difference. We then need to see if both of these are perfect squares. T squared is just t times t, so that's a perfect square. 81 is 9 times 9, so that's a perfect square. So we can just write out our answer as the square root of the first term first. The square root of t squared is just t, so we write a t here and a t here. The square root of the second term goes second. Square root of 81 is 9, so we put a 9 here at the end and a 9 here at the end. And then we just put a plus sign and a minus sign in between. And that's the difference of two squares pattern. Number 6 is a little bit trickier to do, but we still want to talk through it. With number 6, we already know that 81 is 9 times 9. So we can start off right away by recognizing that the first term is the square root of this first term. We know 9 is going to be the first part. But negative 49k squared is a great, well, specifically 49k squared, is a crazy term to try and figure out if it's a perfect square or not. The good news is, if you want to find the square root of 49k squared, because that'll tell you if it's a perfect square or not, you don't need to do it all at once. You can find the square root of 49 and then multiply it by the square root of k squared. You can split up your term. What's the square root of 49? We know the square root of 49 is 7, because 7 times 7 is 49. And the square root of k squared is just k. So, 49k squared is a perfect square. It's 7k times 7k. So, 7k will be our last term. We put a plus sign and a minus sign, and we're done. And that's 7.7. Thank you so much, everybody, for listening, and I hope you have a terrific rest of your day.